Have you at any point contemplated whether we're genuinely alone in the universe or if there's something else to our reality besides what we see? Consider the possibility that the James Webb Space Telescope, JWST, at long last demonstrates that we live inside a black hole. Join us as we find out more about this weighty news that will make you question all that you thought you knew about the universe. So, what precisely are black holes? They're like something out of a bad dream. Sure, you may have seen them in science fiction movies, but in reality, they're significantly more unnerving. They're not just dark. According to researchers, totally black holes in space are in reality enormous amounts of matter fit into an extraordinarily little region. Imagine a star multiple times more massive than the sun, all packed into a circle the size of New York City. The gravitational pull is so intense that nothing, not even light, can escape from it. Researchers have been captivated by black holes for a long time. They consider objects in space so enormous and dense that they could trap light. The most well-known ideas about black holes were predicted by Einstein's theory of general relativity. Essentially, when a massive star dies, it leaves behind a minuscule dense core. If this core's mass is multiple times that of the sun, gravity overpowers everything else, leading to the formation of a black hole. Identifying black holes is no simple task since they radiate no light. However, researchers have found ways to infer their presence by observing their effects on neighboring matter. For instance, if a black hole passes through a cloud of interstellar matter, it will pull the matter toward it in a process called accretion. Furthermore, when an ordinary star gets too close to a black hole, it can be destroyed, emitting X-rays as it does so. Black holes also have a significant effect on their surroundings. They can consume nearby stars, radiate strong gamma bursts, and even impact the formation of new stars in certain areas while slowing it in others. But where do black holes come from? Picture this. A star, once great and blazing, meets its extreme downfall in a cataclysmic blast called a supernova. From the remnants of these fallen giants, black holes arise. Most black holes are conceived from enormous stars that have reached their divine retirement party in a supernova. Smaller stars, when they die, change into something many refer to as neutron stars, which are very dense but not dense enough to trap light. However, if a star is multiple times the mass of our sun, it succumbs to its own gravitational pull, forming a black hole. As these massive stars break down, something peculiar happens near their surfaces. Time itself begins to play tricks. From the viewpoint of someone far away, time seems to slow down near the event horizon, the final turning point for anything falling into a black hole. It's as if the star's clock ticks at a different speed compared to our own. Now and then, when two smaller black holes collide, they merge to form an even larger and more formidable black hole. If a black hole interacts with a neutron star, they create a cosmic phenomenon that defies comprehension. Researchers have been grappling with the sizes of these enormous phenomena for a long time. Black holes come in two sizes, gigantic and small. There's a hidden secret surrounding them that we just can't unravel. But here's the twist. Small is relative when it comes to black holes. Supermassive black holes, remnants of gigantic stars, can be as massive as 10 to 100 million times the size of the sun. There could be upwards of 10 million to a billion of them in the Milky Way alone, an astonishing number of black holes that could swallow anything in their way. But wait, there's something else. Supermassive black holes are on the opposite end of the spectrum. They are millions, if not billions, of times bigger than the sun and exist at the center of enormous galaxies, including our own Milky Way. It's like a vast void that is pulling everything toward it. Eminent physicist Stephen Hawking talked about black holes throughout his life. His lectures were always insightful, but some of his theories couldn't be confirmed due to a lack of crucial equipment. Anyway, there's hope not too far down the line. A single scientific instrument is changing everything, and we're not ready for it. It goes by the name of the James Webb Space Telescope, or JWST, and it's here to dive into the depths of our universe. Let me tell you, the JWST is no ordinary telescope. It's an engineering marvel, a demonstration of the capability of human ambition. Sure, we've sent other space telescopes before, and they've been doing their jobs just fine, but this one is in a class of its own. The JWST makes the Hubble, which has faithfully served us for a long time, look like a simple tool in the universe. The price tag of this cosmic miracle is an astounding $10 billion. Yes, you heard that right, that's enough zeros to make your head spin. It took the combined efforts of NASA, the European Space Agency, and the Canadian Space Agency to bring this wonder to life, not to mention the invaluable contributions from over 300 universities. However, we must not disregard the dangers that accompany such a remarkable endeavor. I know this isn't an adventure for the faint-hearted. The JWST is venturing into uncharted territory, pushing the limits of what we know and taking us to places we've only dreamed of. Following a successful launch, NASA recently reported that the telescope has enough fuel to last more than twice its base mission life expectancy of 10 years. Since its launch, the JWST has achieved numerous unimaginable accomplishments. It traveled more than 1 million miles to reach its orbit around the Sun, where it will dwell indefinitely. During its journey, the telescope successfully unfurled its massive 5-layer sunshield and its gigantic primary mirror, both of which had to be folded to fit onto the launch vehicle. Now, after NASA has calibrated and aligned it, the telescope is practically all set for full activity. A particularly intriguing aspect concerning the JWST was when NASA announced it had captured its first images of starlight. The primary image taken by the telescope was of a star called HD 8446, resulting in a mosaic of 18 dispersed bright spots from a star's light captured by the 18 mirror segments on the primary mirror. NASA delivered a stunning image of HD 8446 in which 18 unfocused duplicates of the star were united in a purposeful hexagonal formation. Once the observatory effectively adjusts the individual segments of the primary mirror, it will begin the image stacking process, overlaying 18 images into one clear view. Thanks to its advanced technology, the JWST will assist researchers in examining the early phases of the universe after the Big Bang. It will focus on what transpired after the first stars formed, a period known as the Epoch of Reionization. This era refers to when neutral hydrogen was reionized or made to have an electric charge again by radiation from these first stars. This involves looking back billions of years, which is only possible with a powerful telescope like the JWST. The telescope will also help researchers find exoplanets, which are very hard to detect due to their interactions with their host stars. Its strong sensors will allow it to observe these planets in greater detail, including in some cases imaging their atmospheres. Understanding the atmospheres and conditions for planets could assist scientists in better predicting whether certain planets are habitable or not. Aside from focusing on the assembly of galaxies, researchers will look at worlds to see how matter is organized on a massive scale. This, in turn, allows us to see how the universe evolved. The twisting and swirling galaxies we see today emerged from various shapes over millions of years. One of the JWST's objectives is to look back at the earliest galaxies to better understand that evolution. Researchers are also trying to figure out how we got the assortment of galaxies that are visible today and the ongoing ways galaxies form and gather. However, above all, the James Webb Space Telescope will help us answer the most significant questions of all. Are we alone in the universe? And are we living inside a black hole? The JWST has already been on the chase, and guess what? It found compounds called polycyclic aromatic hydrocarbons, PAHs, lurking around those enormous supermassive black holes in 3 active galaxies. PAHs are carbon-based molecules with ring-like structures, like the Gothic children of the universe. They're everywhere, from distant galaxies to comets in our solar system. They're not just intriguing because they could be the building blocks of life, but also because they help astrophysicists track star formation. When ultraviolet radiation hits these PAHs, they produce infrared light, a signal that can be detected by the JWST's mid-infrared instrument, also known as MIRI. That is typically a sign that there are some hot young stars nearby. But wait for the unexpected development. A daring astrophysicist, Ismael Garcia Bernard from Oxford University, decided to look at 3 active galaxies known as NGC 6552, NGC 731, the creepily renowned Stephan's Quintet, and NGC 7469. These galaxies are a multitude of light-years away in the depths of darkness. Now, what Garcia Bernard found will make your hair stand on end. In those focal regions where the black holes rule, he found an overflow of PAHs. Sounds great, right? Well, here's where it gets chilling. The radiation close to those very monstrous black holes altered the PA's very essence. It changed them into larger, electrically neutral versions of themselves. The smaller, electrically charged PAHs evaporated into insignificance, like being depowered by the very darkness. But wait, there's a promising sign. The larger PAHs managed to endure because they found cover inside thin, dense gas-filled clouds. It's as if they found their own protective hiding spots. So, while supermassive black holes are expected to eat up everything around them, they leave behind some signs, like footprints in the cosmic sand. I know what you may be thinking. If black holes can do all of this, might it be conceivable that our universe is inside a black hole? Could the solution to the question that has tormented humanity for eons finally be within reach? With the James Webb Space Telescope, we may soon find out. The telescope will plunge deep into the mysteries of our universe, and who can say for sure what it will find next? As the JWST begins its mission, it vows to alter how we might interpret the universe in ways previously unimaginable. Its cutting-edge technology offers an unprecedented view into infinite phenomena, possibly uncovering mysteries that have eluded researchers for a long time. One of the key areas the JWST will investigate is the development and evolution of the first galaxies. By looking further back in time than ever before, the telescope will be able to observe the early universe's conditions and the cycles that led to the formation of galaxies. This examination could provide insights into how the universe progressed from an almost uniform state to the rich tapestry of galaxies, stars, and planets that we see today. Grasping these early phases is significant for sorting out the history of cosmic evolution and the origins of the structures we see in the universe. The JWST is also prepared to study the mysterious dark matter and dark energy that make up a large portion of the universe's mass energy content. Although these components can't be observed directly, their presence can be inferred through their gravitational effects on visible matter. By observing the behavior of galaxies and galaxy clusters, the JWST can help map the distribution of dark matter and provide clues about the nature of dark energy, which is believed to be driving the accelerated expansion of the universe. This could lead to groundbreaking revelations in how we understand the fundamental forces that govern cosmic dynamics. Another intriguing part of the JWST mission is its capability to identify and analyze exoplanet climates by studying the light that passes through a planet's atmosphere when it transits its host star. The JWST can identify the chemical composition of these atmospheres, including detecting molecules like water vapor, carbon dioxide, and methane, which are crucial for assessing a planet's habitability. The ability to examine exoplanet atmospheres in detail may help researchers identify planets that could support life and prioritize them for further study. In addition, the JWST's high-resolution imaging capabilities will allow it to observe the intricate structure of star-forming regions. These areas, often obscured by dust and gas, are where new stars and planetary systems are born. By looking through the dust with its infrared sensors, the JWST will uncover the complex processes involved in star formation and the evolution of protoplanetary disks. Understanding these processes is essential for appreciating how stars and planetary systems, including our own, came to be. In addition to its scientific goals, the JWST is expected to inspire a new generation of cosmologists and space enthusiasts. Its stunning images and discoveries will capture the public's imagination and highlight the importance of space exploration. By showcasing the universe's beauty and complexity, the JWST will serve as a reminder of the vastness of space and our place within it. The telescope's mission is also a demonstration of global collaboration and the collective effort of thousands of scientists, engineers, and researchers from around the world. The successful organization and operation of the JWST exemplify what can be achieved when nations and organizations work together toward a common goal. This spirit of cooperation not only advances our understanding of the universe, but also fosters goodwill and collaboration among countries. As the JWST continues its journey, it will undoubtedly encounter new and surprising phenomena. The data it gathers will likely lead to questions and discoveries that challenge our current understanding of the universe. Each finding will build upon the previous ones, gradually creating a more complete picture of the cosmos. In the end, the James Webb Space Telescope stands on the brink of revealing significant insights about our universe. Its observations will broaden our knowledge of cosmic origins, the nature of dark matter and dark energy, and the potential for life beyond Earth. As it ventures into the unknown, the JWST will not only advance scientific knowledge, but also inspire wonder and curiosity about the universe we inhabit. The journey of discovery is just beginning, and the telescope's mission represents one of the most ambitious and exciting scientific undertakings of our time.